Welcome back, everybody. We're taking a look at AP Chemistry Unit 6, and this is Section 1 of Solutions and Intermolecular Forces, otherwise known as IMFs. In this particular section, we're taking a look at solutions themselves, and within solutions, we have lots of different ways to describe how strong they are, ways to express their concentrations. And so let's do a quick review before we begin anything. Let's take a look at a scenario of something that's a sugar and water solution. And the reason I wanted to back up and do this review is because we have some terms that are going to apply. Whenever we express concentrations, we're always going to be referring to two things, the solute as well as the solvent. And so my solute is the thing that gets dissolved. The thing that does my dissolving is my solvent. So we're going to have to pick those scenarios apart every single time, figure out who's getting dissolved, who does my dissolving. So if it's the case of sugar and water, if my water molecules are out here, what's going to happen is they're going to come in contact with the sugar molecules. And essentially, because of intermolecular forces, my water will gradually lift away those individual molecules that are stuck together with sugar and spread out and form different concentrations. Okay, so that's the concept behind what we're going to be doing in this chapter. And in the first case, whenever we see a scenario, we have to pick apart what's going on in there in terms of solute and solvent. And so we have about 1.00 grams of ethanol is dissolved in. Now the prompt is telling me already that my solute is going to be my ethanol because it says it's getting dissolved into my water. Okay? And they want to know how to express those concentrations in 4 different ways. We've already done the molarity one, haven't we? We've taken a look at molarity, a capital M, as a function of moles of solute over liters of solution. Now that phrase, we've got to be careful. Whenever we see solution, there's 2 things here. That's solute and my solvent. And that scenario is going to come up quite often throughout this entire chapter, seeing that sometimes we have solute, sometimes solvent, and sometimes solution. Okay, so we've got all the tools to figure out, in the first case, my molarity. But notice that I'm given grams of solute. Okay, and we need to find that into moles of solute. So I convert my grams of ethanol into moles. And I've already done the math on this one, so that's 46.07 grams of ethanol per mole. And so that will give me 0.0217 moles of ethanol. Okay? And so if I know the moles of ethanol, I've got to find out my liters of solution. But I've got a problem. I've got grams. So this is telling me that I've got a density of 1 gram per milliliter. So if I have 1 gram per milliliter, that means that I have 1 milliliter of this as well. But I need it in liters. And so that's going to end up being a 0.001 liters of this. My water, same deal. I've got 100 grams. That means I've got 100 milliliters. But if I'm going to convert that into liters, that's a 0.100 liters. And so now I've got all the pieces to find my molarity. I have a 0.0217 moles of ethanol over a 0.101 liters of solution. A 0.101 liters of solution, I end up with an answer of 0.215 molar solution. Okay, let's take a look now at a mole fraction. Well, I've already found my moles of solute, so that's easy. My moles of solute ended up being a 0.0217 moles of ethanol. Okay, but notice that it's mole fraction of the solution. And so I take my 0.0217 plus, I don't know the moles of my water. I know grams. So 100 grams of water, I've got to convert that, don't I? So I take 100 grams divided by 18. That will give me moles of water. All right, and that ends up being, let's see, 5.56 moles of water. Okay, so I have 0.0217 plus my 5.56 moles of water. I end up with a mole fraction. Then if I divide 0.0217 divided by the sum of those two, I end up with a mole fraction of 0.00389. Now that's of my ethanol. Now notice this is a decimal. This is one of the things I don't like because we always refer to it as a mole fraction. Just keep in mind that's a decimal. If we want to know the mole fraction of my water, I would simply take 1 minus my ethanol. Okay, and so the two of those together, because it's a decimal, the two of those added up together will be 1. All right, let's find a mass percent now. The name itself tells me we leave it in mass. And so I simply take a look at the problem. I have 1.00 grams of ethanol divided by solution. Now remember, my solution is my solute plus my solvent, and it's 100 grams. Now remember, this is mass, so we leave it in grams. This is not moles, and we multiply that by 100%. I end up with an answer here of 0.989% ethanol. Okay, so pretty straightforward. Watch out though, it's of the entire solution, so you have to add the two together. Last one, this is molality. Don't confuse that with molarity. Molarity is the capital M. Molality is a lowercase italicized m. I tend to write it like this. And so you can see the difference between my M in a molarity versus my M in molality. Okay, so I take a look and I see I keep it in moles. So it's similar, or it's related to my molarity. I had, in this case, 0.0217 moles of my ethanol, but I need in kilograms of solvent, just my solvent. And so I saw that I had water as my solvent, and that's 0.1 kilograms. Okay, it's not solution, it's solvent. And so I end up with an answer of a 0.217 molality. Okay, so that's how we express those in a multitude of ways. Always take a look at your prompt and see how this works. So let's apply this in some different examples here. Okay, first of all, I have a solution where we have 4.25 molar lithium chloride, and we have 1.5 liters. Now we have a problem here because if you remember, 4.25 molar is a function of moles of lithium chloride per liter of solution. Okay, so I had 4.25 moles of lithium chloride for every liter, but I have a liter and a half, don't I? And so if I account for that liter and a half, I can see how many moles exactly I've got in the solution. I have 6.375 moles of lithium chloride in that solution because I have a liter and a half. So I have 4.25 per liter, but I have to add another half a liter's worth into there. Okay, so now I can find my first scenario, my mass percent. Okay, so mass percent, remember we got to convert everything to grams. So if I had 6.375 moles of lithium chloride, and I want to convert that into grams. Lithium chloride, the formula mass, is 78 grams. And so I start out with 497.25 grams of lithium chloride. Okay, that's just 6.375 times 78. So that's my grams of lithium chloride. But I want to find the mass percent. And I have 1.5 liters of entire solution. And mass percent is mass of your solute over mass of the entire solution. So if I have 1.5 liters worth, and this is the density, I've got all my pieces. 1.5 liters is the same as 1,500 milliliters. And so if I have 1 milliliter has a mass of 1.126 grams, the entire solution then has a mass of 1689. And if I multiply that by 100%, I end up with 29.4% lithium chloride solution. Okay, so pretty straightforward. Watch out for those little tricks though, converting your density. Now let's take a look at the second thing that they're asking for. They're asking about molality. Now remember, molality is moles of solute over kilograms of your solvent. Uh-oh, remember, this is grams of solution. How many grams of solute did I have? Well, I had 497.25. So if I subtract that 497.25, I can get my grams of water, can't I? The entire solution was 1689. If I subtract off my lithium chloride off of that, I end up with 1191.75 grams. Okay? So I've got all my pieces to find my molality, don't I? I knew that I had 6.375 moles of lithium chloride. I have 1.19175 kilograms of water. Remember, this is grams. We need it in kilograms. All right, so I end up with a molality in this case of 5.35 molal solution. You see this lowercase italicized m, or you can write out molal. I know that looks weird, but that's how we express molality. Now, the last one is dealing with mole fraction. Cool, I've got all these parts because I have to find moles of everything. All right, so mole fraction, once again, I can use my 6.375 moles of lithium chloride divided by 6.375 moles of lithium chloride plus my moles of water. Well, I know how many grams of water I have. Let's convert my grams of water into moles of water. So if I do that part, I end up with 66.2 moles of water. Okay, 66.2 moles of water. So you see how all these little parts, even though it's three separate problems, they all tie together in different ways. I end up with my formula mass, or sorry, my mole fraction of my lithium chloride being a 0.088. Again, that's going to be of my lithium chloride. I could find a mole fraction of my water by subtracting that from 1. Okay, so that's how to do that particular problem. Let's go on to a couple others. Okay, this is a long section in here, but it's taking a look at a couple different twists. All right. So the electrolyte in an automobile lead storage battery, so winterizing your battery, is sulfuric acid. That's 3.75, and it has a density of this. Calculate again the same three things that we've been doing. So let's take and solve for those. All right, 3.75 molar. That means that I'm going to have 3.75 moles of sulfuric acid, H2SO4, per 1 liter of the solution. Okay? And in this particular case, they don't tell me how much, so we just know that we've got that many moles per liter. Okay, so let's find a mass percent from this. If I have 1 liter solution, they didn't tell me how much. Let's go ahead and assume that we have 1 liter of solution then. That gives me 3.75 moles of sulfuric acid to work with. And if I want to find my, first of all, my mass percent, let's convert my moles of acid into grams. So my mole of acid to 98 grams. That will give me 368 grams of sulfuric acid. Okay, now I have a liter's worth of solution. Okay, so the density of my solution is 1.230. So if I have 1 liter's worth, that's 1,000 milliliters, and I can convert my 1 milliliter to 1.230 grams, I end up with 1,230 grams of solution. Cool. So if I take a look and divide those, 1230 times 100%, I end up with a formula mass, or sorry, a percent in this case, of 29.9%. All right, so that deals with my mass percent. Let's take a look at molality. That is moles of solute, and I already have my moles of solute of a 3.75 moles of sulfuric acid, H2SO4, over kilograms of solvent. Uh-oh, I don't know my kilograms of solvent. I do know that I have 1230 grams of solution, and I do know that I had, in this case, 368 grams of sulfuric acid, SO4. So how much water did I have present? Okay, in this particular case, I had 862 grams of water. Now remember, molality is moles over kilograms, so that's a 0.862 kilograms of water. And so my molality in this case ends up being a 4.35 molo. Last part, we're taking a look at the mole fraction. Well, I know that I've got to convert my water into grams. So 18 grams of water is 1 mole of water, and so I end up with 47.9 moles of water. I already had my sulfuric acid, so 3.75 divided by my 3.75 plus my 47.9. Okay, these are all in moles now, and so I end up with a mole fraction of 0.0726. That's my sulfuric acid mole fraction. Okay, so pretty straightforward if we just know our definitions. Moles per kilogram, we have the percent solution is going to be in grams, and then molality, yeah, everything is taken care of in this case. All my units are going to agree. All right, last one. There's a lot of stuff to go through in this particular section. We have different properties within the sulfuric acid once again, and I want to find from a mass percent, I want to find my molarity and molality and mole fraction. So remember, we've been finding from a molarity aspect. And so my mass percent, if I see that it's 95 mass percent, that means that I have 95 grams of sulfuric acid over 95 grams of sulfuric acid. And so how much water would it have? Because 95% is 95 over 100, isn't it? So I would have 5 grams of water in here. Okay, some pretty strong stuff. So that's the intuitive step we have to go behind all of this. We have 100 grams of solution, and we found that we had 5 grams of water within the solution. Okay, so let's find our molarity. If I have a molarity out of this, that is moles of solute, so I'm going to have to convert my 95 grams of sulfuric acid, and I need to convert that into moles. So 95 grams is 98 grams per mole. And so in this solution, I have a 0.9694 moles of sulfuric. I have 100 grams of solution. Okay, 100 grams of solution, and here's my density. Okay, so 100 grams of solution, 100 grams solution, and I want to go 1.84 grams per cubic centimeter. Okay, we got to remember a couple of just kind of intuitive things along the way with this. So if I have that many grams per solution, remember 1 cubic centimeter equals 1 milliliter, which is 0.001 liters, isn't it? So if I do all of those conversions along the way, divide that, I end up with 0.0543 liters. Okay? So 100 grams of solution, I divide by 1.84, and then remember, I have to multiply that by 0.001. So I end up with 0.9694 divided by 0.05435. I guess I should have a 5 here. And I end up with my molarity being a 17.8 m. That's pretty strong. Okay. Remember, it's 95%. So now I have all the pieces to do the next one. If molality, and that's going to be a 0.9694 moles of sulfuric, and molality, remember, is per kilogram of solvent. Well, I had 5 grams, didn't I? If I have 5 grams, that's a 0.005 kilograms. And so I end up with 194 molal solution. Okay, last one is mole fraction. And if I take my 5 grams and I divide that to get my moles, 18 grams of water per mole, I end up with a 0.3 moles of water. Okay, so if it's going to be a mole fraction, I take my 0.96 0.9694 moles of solute over my 0.9694 moles of solute plus my zero point 0.3 moles of water. And so I end up with a mole fraction of a 0.76 mole fraction for my sulfuric acid. Notice that's pretty high. So I have a 0.24 mole fraction of water there. Okay, so just kind of looking at those problems, that's pretty straightforward math. Just know your equation. And this is the last piece, guys. I'm taking a look at a dilution, and we've done this before. So a solid dilution, if we were going to take a look at a solid dilution, this is basically saying how many grams of salt. Let me switch over to my pen. How many grams of salt to make, so just as an example, 750 milliliters of a 0.2 molar solution of sodium chloride. Okay, so this is basically how it would take something like that. A 0.2 means I'm going to have 0.2 moles over 1 liter. And if I have 750 milliliters worth, then I take and I go, okay, that's 750 milliliters is 0.750 liters, and that's going to be a 0.05 moles of sodium chloride. Now, that's moles. If I'm going to ask how to make it, again, this is just a review problem. We've done these before. 1 mole of sodium chloride is 58.5 grams. And so I'm going to get 8.8 grams of sodium chloride. And then I put that into my container, and I'm going to fill up to that 750 milliliter mark. Okay, watch the bottom of the meniscus hitting that, and we just fill it up to that point. Now, if it's a liquid dilution with this, I can ask the question, how much stock solution, once again, we've done these before, is needed to make, let's take an example of a 1.5 liter of 0.003 molar solution from above. Now, what I'm asking here is, if I have this solution, I have a 1.5 liters worth, and it's only going to be 0.2 molar strength, okay? I need to make 1.5 liters of 0.03 molar solution. So I just basically plug the numbers in. I have, on my dilution side, I need 0.03 molar solution, and I need to have 1.5 liters worth. Keep that label in there so we know what we're dealing with. Okay, my stock solution is my stronger stuff. That would be a 0.2 molar solution. And so I basically solve for X, and that will be in liters. And so my second volume then would end up being a 0.225 liters of stock solution. So if I took this one more step, I could subtract off my 0.225 from my 1.5 liters. I could actually pre-measure out my water as well, couldn't I? So it's going to be slightly over 1. What is it? Somewhere around 1.23 liters worth of water added to this. Or I could just simply say add water until I hit the 1.5 liter mark. Whew, that's a lot of stuff, guys. But taking a look at these problems, it's just reminding ourselves of some things that we've done before in previous chapters with the mole. But now we can take a look at it in terms of other ways to express different solutions. All right, so that should get us all the tools that we need to get into the next steps. And from there, we should be getting into our assignment. All right, good luck, guys.